Welcome to another video from Callahan Aircraft Services on aircraft structural analysis. Today we're going to talk about allowables. We have the strength of the part. Okay? It's not a property, it's the allowable. After all the testing, we come up with these great numbers so we can analyze the strength using the strength of the material. We have things like the 99% probability with 95% confidence. The effects of temperature on the material. Minimize the probability of a disastrous fatigue failure is out of FAR 25.613. But the important thing to take away is engineering is not an exact science. So on probability, like confidence, history, okay? But what we have to do is use published allowables, and we find our published allowables today in AR MMPDS-01, which supersedes Mill Handbook 5, which superseded AN 5. So a lot of terminology we use today is Mill Handbook 5. It seems to talk easier. It's easier to say than this one. Okay, this is an example of allowables out of Mill Handbook 5. For some reason, the allowables really don't change because materials don't change strength. It is what it is. Okay, so I'm just showing you this. For clad 2024, you got the spec up here and all these fancy numbers with the A and the B basis, thicknesses. Okay, so when you're looking at this and you making like a loaf of bread, you got the soft bread in the middle, the crust on the outside. That's what you have. The thinner it is, the more crust, so it's stronger than when you go over here it gets weaker because it's thicker. It's not that the outside is this allowable, that's the allowable of the whole 3-inch plate. Okay? Got some other allowables down here. So, to go with the A basis or B basis that is in the table, A, B basis, you got two columns. A basis is a 99% probability with a 95% confidence. B basis is a little more liberal. 90% probability of a 95% confidence. Notice, it doesn't say 100%. So nothing is 100% confidence with 100% probability because it's the real world. Therefore, when the CEO of a company asks the chief designer, chief engineer, will it fly? The engineer replies, it should, making the CEO a little nervous because we don't know for a fact. Now, this curve, all those dots, is a representation of data points. From the data points, we use our mathematics to come up with a nice curve. But it's still an approximation of the values. And with all this data, we come up with the A value and the B basis. So when you're using an A basis, your material could be stronger. By the way, this is a little exaggerated. And this dot up here, by the way, is what we call bad data. It's a bad data point, so we throw it out. And that's what I have to say about that today.